My name is Shivom Aggarwal. Today I work as head of R&D projects for EURA. We are a R&D and consulting company headquartered in Brussels, offices in Marseille and Tunis, specifically working on data science, both on the data engineering aspects as well as on the algorithmic side. I'm going to go more detail into the company in a couple of slides. In the past, I have worked in FP6, FP7, Horizon 2020 projects as a repertoire as well as work package manager, as joint leader of the projects. Mostly around smart cities and big data, one on IoT. As I was saying that today I don't like owning a house because the real estate market is something that I don't understand. But I understand a little bit the startup world and the tech side. So I am an investor in 3 startups today. More are coming, hopefully. I worked as a M&A advisor as well as M&A analyst for a bank based out of Munich for a while. I also worked in the past with the Future Society, which is based out of Harvard Kennedy School on the policy making. And I serve as visiting faculties at HSC Paris and EA in Madrid. I have also worked closely with Politécnica de Madrid in the past with their research group on smart buildings. So this is my brief background. I have worked as a hacker, certified ethical hacker, some network skills, so certified network administrator, engineers and stuff. But as one of my Polish colleagues, I loved dangling from the pure tech into the finance, then back into the tech. You need both sides of the world. This was just to say that why Alan asked me to do this small discussion workshop here. I also want to discuss a little bit about given information about our company. Today we are around 110 people across 3 offices. We started purely as an R&D center where we were funding ourselves through regional as well as European grants. But most of the grants come with strings attached. So we wanted to do more free research. We wanted to know where we can spend our money in different ways. So we started doing consulting. For us, consulting was a way to fund our R&D. Over time, we were creating new knowledge through R&D, so margins kept on improving on our consulting side. And more projects, better R&D, both sides work together. Through this, we were also able to create a product factory. So when you are into a software business, an IT business, services is where you can start, but soon, if you want to have good margins, you need to have products which can get you repeated business. So we have been able to create good products for the data engineering side, where we can create automated data flows, data lakes, so that we can launch our solutions directly on them. The way we work today, we work strongly with academics. All the major computer science labs in all big universities in France and Belgium are our direct research partners. How we realize this is we have been able to today so far have done 26 doctoral theses and master thesis inside the company. So you can work with us while doing your doctorate or doing your master's. So we have collaborations with many research labs and universities. We don't like calling our clients, we call them our partners. Because when we work with clients or partners, we do not only work with one. So I'll give you an example. A startup came to us asking for a solution on detecting gender bias in hiring and promotion decisions. What we do is we work with this startup to build the solution, but we also bring from our client portfolio one of the big companies, L'Oreal, to use their solution. So this way we bring the 2 players together at the same time. Users and the final customer are there on the same platform. So this is how we mix between customers and partners. Sometimes we also can bring user groups directly to build the solution, if it's a bigger, wider audience, depending. Yes.
No, please.
Today we specialize in three major areas: high performance distributed computing, where we have our own distributed stack, our own tools designed for this. We works on graphs. We strongly believe in graph theory. We believe that embeddedness and connectedness of the world is reflected in almost all phenomena out there. So when we build any of our solution, we at least try to check whether graph theory will be implemented, could be implemented, whether it has a bit better results. For sure, machine learning, this is where we started. We do reinforcement learning, deep learning models, all that, but not only from a creating solutions perspective, but also doing research. We also work, nowadays, we are also working a lot with federated learning, which is an idea that how can we bring deep learning models directly to the edge. So one idea was that edge devices needs very, very limited processing power. They have very limited resources available, and they don't need to do something big. So what we can design is a dedicated algorithms that work only at the edge. That's the initial thought, and we have some work doing in that. But then we started realizing that no, today TensorFlow is available at the server level, but TensorFlow Lite is available, you can put on a chip. So if they can do big softwares, bring it to the edge, why can't we have a new theoretical angle in it? So what we started looking at is compression. Can we compress deep neural networks and bring it to the edge? Today, in my company, we are able to achieve 97% compression. What it means? It means is what we theoretically believe that in any neural network, there exists a brain. And if you're able to find that brain, then you can chop off all the other nodes and keep the same accuracy level while using almost very little resources. So with 3% of the resources, you can perform the same functions as the whole neural network. Today we are doing 97%, and we are trying to find a project with STMicro, for example, to do a joint development where our compressed neural network will go as a home AI in all their chips. Now the idea is one step further, is that today when we talk about learning, in this case, learning will happen at one edge device, but that will remain a very localized learning. What we have done, checked through our simulations at least, that if there is a way that you can not only figure out where are the local maximas and minimas, but if you can find a way to find a global maxima minima and then bring it back into the device. Okay. So what we are proposing is that you use a CNN, a convoluted neural network at the server level, you compress it, the same neural network, compress it very to whatever extent you can. We want to achieve 99%. And you bring it to all the devices. Okay. And these are talking. So this way, the edge device gets updated with the global knowledge that is coming from all the other devices. Today we have done over 100 data science projects. We have been in business for 11 years. We make millions of revenues. I can't give you the exact number.
I will ask Google.
Yes, you can try. Today we have 15 PhDs full-time working with us in the company. We have around 40 master's students who have done masters. Rest are developers. Some of our publications in different journals that we try to publish. It's very strong. R&D has to remain core of our DNA. From this, I would like to say this very specifically is that the way I envision, it may be a little different from what my founders envision the company. I envision the company as a middle link between pure industry and academia. We do applied research, and we are very good, decently good in doing research which has direct application into the industry, and we do research with the industry. So most of our projects actually work as an external R&D center, where client will own the intellectual property and we will build it for them. Now, why cyber world is interesting for me is because my personal background, I have always been interested in this. I have had the fortune of working with the European Research Commission before as an advisor, also with many Indian government organizations as advisors. Today, while working as head of R&D projects, I'm also the company's representative in most international organizations. So I'm also representative in Etsy. I personally feel that your project going to benefit heavily in working with Etsy. So in Etsy, we became a founding member of a new industry group called Securing AI. So there is a new group called Securing AI, where we are one of the founding members, and we are trying to tackle two problems in there, because the securing AI is a very broad problem. So we are tackling two specific issues. First issue is how do you corrupt AI systems? So creating all kind of threat ontologies that exist for existing AI systems. So you build a predictive maintenance for an industry 4.0, but you know that the system is more corruptible than the system that was there before. The second thing that we try to tackle in this is when you use AI for offensive. How many of you are aware of polymorphic codes or polymorphic viruses? So today we have moved away from the world where someone will create a malware and launch it. Today, good hackers are building algorithms. So these algorithms have two functions. First, they are generative algorithms. That means that they are designed to generate codes. Okay. Now these can then be modified. We have a lot of work on generative algorithms. There is a new European project call that we are submitting a new project in automating the process of building applications. The complexity there is this, that when you're building antiviruses today, how you build security in a system or any kind of filtering or firewall or any kind of security system, they work at the code level. They analyze code and they find patterns in it and classify this is a virus, this is a worm, this is a specific kind of malware, this is how we're going to stop it. Problem, if you're using a generative algorithm, then it can modify its own code depending on the virus of the system. So I designed a worm that is supposed to go and find me names of all or social security number of all the employees in your company. That's what my worm is supposed to do. When it goes into your system, the moment it enters your firewall and your other security IDPS system, intrusion detection prevention systems, suddenly say, oh, this is a worm, because it codes looks like a worm. The moment that happens, they can detect that security system has detected them. And the moment that happens, they change their code. So when the final execution is happening to stop you or kill you, they can't recognize anymore. So we are moving away from that world. We are moving into an algorithmic malware world. And any new cybersecurity solution has to be aware that you are not dealing with human coders anymore. So my argument in this is simple. An AI can only defend against an AI. So if we are building security solutions today, they have to be algorithmic. We cannot do human-based solutions in there. Besides this, there are many, there is a technical committee which is almost 10 years old in Etsy called Cyber Technical Committee, where all the national cyber security centers of all European countries are represented. So there have been a lot of outcomes coming out of this for last 10 years. So it could be very interesting to know what rest of the world is doing in this.
You during the break, you spoke also about the ontology.
Yes.
This is also Etsy that is working.
Yes. So in my group, I am in charge of a work item, work package of data supply chain. So we are building a report on how data in itself is crucial to secure if you want to secure AI systems. Because the first way to corrupt an AI system is to corrupt the data. Yeah. If you are doing that, then everything else is done. So then we are identifying which parts of the supply chain of the data can be easily corruptible and what kind of systems can be built. So that's what I'm saying. And we did not start from scratch either. We took threat ontologies already described by a European Commission report that came out 2017 about cyber ontologies. So that's where we started. So what I am saying is do not reinvent the wheel. There are so much work done already on cybersecurity which you can directly use. And I can tell you that HC will be very happy to collaborate and disseminate their work to you in any form. And if you are interested in this group, being one of the members there, I can easily help connecting the two. Another organization, I came back from Athens this Sunday. There is a new organization that has been created called AI for EU. If you are not aware, it may be interesting to be aware. This is also like yours, it's an EU funded project. I think so far they have received 3 million and it's a slightly different than yours because they're going to get direct funding possibilities of 20 million. They will get 20 million to be invested from them into other platforms and companies. So this is a industry and research group led by Thales today where they have created a platform. AI for EU is a platform where you can create consortiums, you can find experts in different domains of AI, you can ask questions, startups are there. So this could be interesting for you to recruit startups, to find solutions, as well as disseminate information back. One aspect of AI for EU is, of course, cybersecurity. So they will also be doing some work on cybersecurity there.
And they offer cascade funding.
Yes, they have their own funding through the European Union. I think around 20 million, and they can give up to 5 million per project. Okay. Then there is another industry cluster. This is a pure industry cluster called Big Data Value Association. This is led by Siemens. Since your project is very much focused on lighting, Siemens is a big player out there, and they are investing heavily in this organization. And one of the work they are also doing is around cybersecurity. Okay. One of the things that I wanted to touch is things happening out there. Today, hackers show how easy it is to hack people while walking in the public. Have you seen this? Evil twin attack. It's a simple thing. It's what we call a session hijacking. I would love to show this. I don't have the right system these days, but so what you do is you make a briefcase and you put a screen on top. Okay, inside the briefcase you have your laptop. Okay, and I'm going around here. Okay, I'm walking. And whatever my friend is typing here starts appearing here. Then I walk here, whatever Facebook messaging you're typing starts appearing here. So wherever I go, whose session is open, whose Wi-Fi is open or anything is open, I hijack immediately. This is just to show that how easy it is to hack in real time in real public. And what these guys did, they walked in Manhattan with their briefcase showing this in public. So you're texting and suddenly you see, oh my God, my texts are there. So. But
when you use only the open source internet or even if
No, any internet. Any, as long as you leave your Wi-Fi open. As your Wi-Fi is open. So you let your Wi-Fi on. That's all. You're not even connected to anything. That's all. You don't need more. Nearly half of Norway's population lost their medical data. So the secured server on which Norway's medical data was stored got hacked, and the hackers took it and put it online. 2.9 million Norwegians' health records are available online for free. Someone stole $500 million from a Japanese cryptocurrency exchange. You know what they did? Rather than filing a police complaint against them, they declared bankruptcy and they closed it down. So hacker went away with $500 million. Let me ask you a very simple question. How many hackers you know have been convicted of serious crimes? So what I'm indirectly trying to say is that
the only one.
Only one.
Because it was the beginning.
Yes, it was the beginning in the early days. What I'm trying to say is today, being a hacker is a very lucrative career. Money is immense. You are always talking and interacting with very intellectual people. You can travel a lot today easily. It's a very interesting lifestyle for a lot of people. And the cost is very low because there are not a lot of risks out there that even if you screw up, nobody is really coming after you.
There's no contract.
So this is what I'm saying is that we have to very much understand what they are doing on the other side before we start building our own systems. And I want to bring very simply where it all started. It all started with the starting of internet. ARPANET was the precursor to internet, and it started in universities. The hacking culture started in universities. Students are the ones who love knowing the unknown. I don't know what is behind this door. I want to sneak in. Rather than opening the door, I first want to check in, then at some point someone will come and open the door. That's where what happened. Early days, if you look at hackers, who would be called hackers, it was Richard Stallman. He was called hacker. The founder of free software movement. Linus Torvalds, in my view, the true genius. Without him, we may not have much modern systems. If you look back, we have reinvented so many other things, except one of the core aspects of our technology, the kernel. The kernel of an operating system. After Linus Torvalds designed it, it's still the same. Nobody has really changed or reinvented or did anything about it. Microsoft uses the same, Macintosh uses the same, all Linux versions uses the same, slightly different on top, yes.
But Torvalds developed it as a student and he has grasped knowledge from the Unix,
Yes.
which was developed on the university, not by the company.
Exactly.
As a C language also.
True. So what I'm trying to say is that great hackers are still based in universities. When we were doing this, the first hacking project we did was very simple. Our dorm in the university was completely cut off from our university system where the labs and classes will be happening. So tomorrow was an exam of Java programming. What we did is we found a way to hack into the lab and plant all the possible Java codes in all the systems beforehand. So when you go to the exam, you double click and you have it. I mean, it is simple. People try to find very simple solutions to the problems, but this is where it starts. So if we want to tackle this, we should need to go back to the universities. In 1984, Ted Koppel on ABC World News said, there have been a lot of stories recently about computer hackers, high-tech experts who use their personal computers to break into big computer systems. This used to be the definition of hackers. Today. Has changed. We live in the days of anonymous. Things have moved away from people who would do it in garages and small. People work in teams. When I was working, we were a team of 6 people. 2 were on the offense and 4 were on the defense. Covering your tracks is easy. Is the most difficult part. Today, stealing 10 million from a bank, easy. Taking it out of the system and using it is very difficult. And the most difficult part is save yourself. So you
Hide the trucks,
Don't buy Ferrari.
exactly. I mean, there are techniques. I mean, what we were things are being recorded. I can't disclose everything. Maybe after the talk. How do you take money once you have stolen money? How do you take it out? There are ideas. There are ways to do it. Anonymous. How many of you are aware of Anonymous?
We've heard about them.
Anything anyone wants to say what is Anonymous, who they are?
It is still recorded.
It is still So here, Anonymous. So Anonymous is an organization which I wanted to join at some point. We need to be very much aware who they are, what they are. In my view, there are no scientific studies on this because there is no information available per se. It's one of the largest, if not the largest, hacking group out there. And they are hacktivists, which means what is their motivation? They don't want to steal money, most cases. If they are stealing money, then it is for something bigger. So they steal money to fund projects. And the project has something bigger. So their motivations are social or political.
Okay.
So it has happened that a CEO said that in a public gathering, a CEO of a Fortune 500 company talked about privacy rights, patents. That how important are patents for the company, and patents should not be available, discontinued after 10 years or 15 years. He was attacked by Anonymous. Anonymous supports complete freedom of access of information to anyone, available to everyone for free. So if you support patents, you are against Anonymous. So they went after him. They hacked his laptop and put all his emails out in public domain. He got fired, company stock prices tanked. So those things can happen. Today, Anonymous works as a collective where you don't have any leaders. It's all a project-based organization. You have to create projects to attract interest and project teams, and then you find funds. They have hacked government agencies of US, Israel, Tunisia, Uganda, child pornographic sites they like shutting down, copyright agencies all over the world, church, corporations like PayPal, MasterCard, Visa, Sony. They have hacked, shut down the systems. They call themselves freedom fighters or digital Robin Hoods. That was my attraction to them. While critics describe them as cyber lynch mob or digital cyber terrorists. It's up to you what you want to believe or like to believe. But they are 100 Times magazine considered them 100 most influential people in 2012. So what my simple message is that we need to be aware who they are, what they are doing. We talked a lot about, you may go to many other situations or conferences where they will talk about the sophisticated ways of breaching firewalls, of breaching systems, hacking chips, smart homes, smart buildings. But most effective way of hacking is actually not hacking. It's social engineering. So when you build cybersecurity solutions, you need to have social engineering training with them. If you don't have them, this is the worst. So the easiest to hack any organization, you buy a bunch of pen drives, infect them all, and throw them outside the gate of the company. That's all. Someone will pick one system and plug it in. That's all you need. And this is a tried and tested. You can try it in a big corporation, small startup, university, libraries. It works.
The European project gadgets, the USBs.
So
everybody gave you one.
There is another project now, the public USB power of the phone.
Yes.
The
Yes.
one that you can use.
It can be hacked.
Yeah.
If you want, if you plug in to replicate the battery.
Yeah. So
basically.
basically these malwares were designed for smart grids. How to hack smart grids? These systems are designed to hack electric circuits.
Okay.
How do you change the power output? That's what they do. And they can increase the power output to such extent that it blasts. This is one application. The bigger application is in SCADA systems. If you're aware. Stuxnet. Stuxnet actually, what I would say is the early man. Is the early man of this world. Now we have moved further. We have systems like Duku, DUKU. where Stuxnet is just a small piece of it. So it does one specific function. It's a worm. It's not even a virus. Just for clarification, how many of you know the difference between a virus and a worm? I'll give a brief example. This is what I do in my classes. So what you can think about, a virus is a malware which needs a host file system to transfer itself. You've seen movie Matrix?
Yes.
Okay, so in movie Matrix you have Agent Smith.
Yes.
How does Agent Smith transfers itself? He puts his hand into other programs and they become Agent Smith. He's a virus. A virus can only transfer itself when it inserts its own copies into other file systems and they become the virus. A worm is different. Worm is more like an amoeba. It's 1, it's 2, it's 4, it's 16, 32, it's keep on increasing. And so it doesn't need any host file system. So if you are trying to infect maximum number of things, but you can't do much about it, you can't steal data, but it's a disruption, worms are a better tool than viruses. But if you are stealing something or the operation is sophisticated, viruses are better, but they are easily detectable. So what I'm saying is that there are many ways to do social engineering. We have phishing, we have pretexting. Phishing is the old way where you get a link which looks like the original one, but it is not. Pretexting is when they create a good pretext to steal information from people. And this actually works. Easiest way to hack a system, a company system, is not to hack it from outside, but from inside. So yeah, you just put a dress, put IT systems something, look like an IT guy, and just walk in any company. And you have direct access. They will show you the access to my servers. This works. Baiting is another. This is the idea where you can throw pen drives and stuff outside. Quid pro quo is another one. Quid pro quo is that you actually promise a gift in exchange of information. This works very well as well. You get the list phone numbers of all the people in the company, in the employees, and you start calling one by one, okay, to the people and ask them their username password. And 40% of the employees on an average give up their username passwords just to fill up a survey in return for a pen. You can try. So these are some of the things that we need to be a little bit more aware of this. There was an article, The Year of Cyber Warfare. Why I was talking about, I like using the word cyber weapons and cyber warfare because that's where we are today. We have moved away from the world of malwares and cybersecurity. We are more into this world. Why it is the case? Because in mid-20th century, the military power was hard military power, where you need to have guns and tanks and foot soldiers. But after the fall of Berlin Wall, it was the soft power that made sense. The culture, the language, the education, the technology that you can transfer. In 2016, we witnessed another dramatic shift in denomination of power, which is cyber power. If today you have to bet your money on the cyber power, which country will you bet on? Which country you will bet your money in a hypothetical situation will be the cyber power of the tomorrow, of the future?
China.
Why China? Why not United States? Why not Europe or UK or France individually? Why China? America has as good hackers. Even Australia has brilliant hackers. I mean, the first culture of hacking started in almost parallel to United States was in Melbourne, where Julian Assange comes out. Any ideas? So one of the things I love doing as a personal hobby is looking at the defense budgets of different countries.
Because I wanted to say that there is like governmental agreement on this.
Yes.
In China.
True. I want to skip quickly to that slide if I have that, since we are talking about it.
It will be able to download that.
Yes.
So it was the right answer.
So it's almost the right. So China isn't only investing heavily in AI. So this you can look at. So if you look at defense budget of China and America, you see America has almost 10 times defense budget overall than China. But you look at the AI allocation on this,
Is the smallest one.
is very small. But if you look at allocation of AI for China budget, it's almost twice the size of America.
Consider Russia.
Russia is very important player. I think if that will be the second choice, because they truly have started testing their cyber defenses. Did you know that did you hear the Russia try to disconnect themselves from the internet?
Yeah.
No.
They did. The only two countries who have some success in isolating themselves from the rest of the tech world, China and Russia, and their approaches are very different. So Chinese approach is based on a great firewall, a great filtering system. They control what goes in and out. Russia was a very different idea. Russia truly wanted to see that can they make Russia an isolated internet, in the sense that all the websites or all the servers within Russian boundary can talk to each other, but nothing can go out or nothing can come in. And they played with very simple idea of DNS. So they talked to all their ISPs and they said, stop all, clear up all your DNS files. So if you know how the domain name server works and how you go from google.com to the actual IP address.
Actually, DNS is US
Yes.
governance, so if you change that, that's the system way to change it. Very easy.
So that's one thing, and the other very important thing, which is very different from China, for China, is data. In 2016, National People's Congress in 2016 passed a law by virtue of which they can make available the huge surveillance data they have been collecting for decades on their own citizens to any startup or public enterprise who wants to build AI products. And they have huge amounts of data.
To sell the data.
I don't think it is meant to be sold. It's just for them to train their models and bring solutions. They're not going to buy. It will be more like a repository at the European level where anyone can access it.
So there is a close to zettabyte capacity
Yes.
data center in Navajo.
Navajo, yeah.
Which is designed just for the same purposes, but not for selling. It's a national security.
It's a national asset.
Treasure.
Yeah, it's a treasure. And we see another implementation of the same data set, which is their national social scoring system. You're aware?
Yes, we know it.
Yes. So
Credit points.
So you as a citizen, the way you live your social life gives you social credit. So this social credit or your social score impacts your actual financial credit. Can you get a loan from bank? What interest you will pay to the bank? There are over 2,000 Chinese, I think, or I have to check my number exactly, who have been banned from flying because they talk negatively about the state. So this score talks about, they can put any restrictions based on your score. You may be denied to enter somewhere, to go somewhere. It has all kind of impact. This is already in place. Okay, I'll quickly go to this idea. What is happening out there? Today there is another key difference into the cyber world, the cybersecurity world, which is the mix of nation states with other pressure groups. Along with ISIS, we did not talk a lot about another organization which played a huge role, Syrian Electronic Army. They are the electronic army. So they are the ones who are handling all their recruitment. Recruitment doesn't happen on the ground. It happens over the internet. So on one side, Twitter and Facebook, they're closing down their accounts everywhere. So you need someone, a counter system to make this happen. On the other side, all kind of military actions are killing their internet. They have to secure their internal communication system. So you need an internal wing, I would say, to do this.
Some military drones which were hijacked.
Yes.
For the Syria.
So they were big player in making it prop up. Otherwise, it will not work easily. North Korea was suspected of hacking a way to achieve a diplomatic goal. So it's not only hacker groups are using it for social or political reasons. It's states already started doing it for political reasons. That's why we have moved into a cyber war kind of era. FBI publicly accused hacking Sony Pictures in 2014, exposing confidential information. It was a hack of a Japanese company targeted by an Asian state with the aim of pressuring the US arm of the company over a movie. It's a geopolitical end. That's a geopolitical goal that you're trying to achieve through this. 2016 election, I don't have to say anything. Growth of AI is boosting both the defense side. I'm discussing with Fortinet, which is a big cybersecurity company based out of France. It's definitely helping to build better secured products. We can do better complex event processing today to build very good IDPS systems. And then we have the invention of honeypots. Honeypots, aware honeypots? No. So honeypots is a kind of security tool which creates a virtual copy of your whole security apparatus in front of it.
Okay.
So it cheats the virus of the world.
Yes.
It's
So
appealing for some.
So basically, as a hacker, I'm doing a real-time hacking. So I come into the system, and in this system, I have a virtual copy of the firewall and all the directories and database, everything. But this is all fake. Nothing is real. And we designed this in a way like a Russian doll. You open one, there is another one. You open one, there is another one.
So we need a pull strategy.
So basically, you keep the hacker stuck in this honeypot while you are hacking him back. Figuring out where he comes from, what channels are open on his side. So it's an automated tool to hack back into the system. Now, honeypots were very controversial. In Europe, in US, yes. In China, yes. And even in India, it was fine. In Europe, it was complicated because as an individual, do I have the right to hack something, even if the hacker has hacked me? I mean, legally, it was complicated. They hacked me, but do I have the right to hack them? Do I have the right to steal from the stealer, from the robber, from the thief? So that was the argument. Finally, they agreed it's a good security tool to have. Drone swarms, these are already happening. This is a good military application of AI-based cyber weapons. They are laser-guided small drones, so they are much better for offensive. So you have to realize that when we started designing the initial drone systems, they were very much about going to a specific target, dropping, coming back. They did not think about that tomorrow you may have systems on the ground there which will try to attack it. And if you look at American drones, they are being shot down everywhere, whether it's Afghanistan or Iraq, they are being shot down. So they have to start thinking about a new way of doing this, so something which can defend itself. So they miniaturize it and they use the concepts of flying birds in a flock. So if something shoots, they split up, then they come back. So these are drone swarms, not individual, and they are fitted with small laser guided missiles as well as small guns. They are perfect assassination tools. AI is likely to revolutionize the power of the bad actors to threaten everyday life. AI could be used to lower the barriers to entry for carrying out damaging attacks. What is the problem? Today, the problem was not there that much in 10 years ago. The reason was that cyber weapons were not democratized. Tomorrow they are democratized. Stuxnet is available for free for anyone.
And the tools to build up another one.
Yes, you have everything available for free. So it's truly democratized. Any engineer, if we call them in, can go. I mean, they have the right training and knowledge to just go those tools and break any system. Because the systems are not secured anymore, per se. Technology could automate the discovery of critical software bugs rapidly or select the the person who is more likely to commit a financial crime. So, for example, when I send you try to steal money from different people, I can already check which ones will be easier to who will give their username password for their bank to me by default. Just call them.
Finding click addicted on Facebook is quite easy.
Yeah. It could also be used for Facebook style algorithmic profiling to create social engineering attacks designed to maximize that a user clicks on a malicious link. So when I send you a message, it will be very different when I send you a message. At the end, the link is the same, but the way the link is coded and everything will be different for the two. We already know what is happening with Uyghurs. I hope that I'm not going to China anytime soon, but I will be in trouble if this video goes live, which will be Uyghurs.
Yeah, they are screening.
Not only screening, I mean,
Yeah.
2 million of those are in prisons. In what we call internment camps. They are very similar to Nazi camps. They are they're educational camps, but you are doing forced labor. You are living apart from your family. Women and children are there, thousands and thousands of those. And China is using all its surveillance system to make it happen. Automated hyper-personalized disinformation campaigns. This is my favorite. So today, what I would like to do is, let's assume all of you have BBC mobile app installed on your phone, okay? And we saw recently there was another conflict between Israel and Palestine. They fired some bombs there and they fired some bombs there. So for example, as a hacker, what I will do is when you see the same news article on this Israel-Palestine conflict, for you, the whole blame is on Israel. For you, when you see the same article, the title, everything is written, it's Palestine, the blame. For me, it will be neutral. So we can change the information that every individual sees depending on what we want to achieve. This can be done through algorithmic AI malwares, where we infect things differently at different people. Okay. So this is what we call automated hyper-personalized disinformation campaigns. And the first time we saw this happening was in United States elections.
Infowars.
Yeah, that's what's happening. AI could simply run denial of attacks, generating so many convincing fake news that legitimate information becomes almost impossible to decipher. There is an organization called OpenAI. You aware? OpenAI is an organization founded by Elon Musk. Elon Musk is one of the guys who is very scared. So there are two kinds of school of thoughts in the AI. One is led by guys like Mark Zuckerberg, even the founder of Uber and others, who strongly believe that it is only a beneficial technology. The other group is Stephen Hawking, Bill Gates, Elon Musk, who strongly believe that it is a technology which can be very, very risky. It's an existential risk. So these guys build an organization, OpenAI, so that we can democratize the design of AI. So anyone can learn and knowledge to design AI systems. Some scientists there designed a fake news generator. This was so good that no other system out there could detect whether the news they are producing is fake or good. They had to shut it down. Because if they let this system while running online, then it will start producing so convincing news that it will be all noise. All information will be noise out there. I would like to close my discussion with one of my friend from Cambridge, Sean, said that we live in a world that could become fraught with day-to-day hazards from misuse of AI. And we need to take ownership of the problem because the risks are real. There are choices that we need to make now. And our report is a call to action for governments, institutions, and individuals across the globe. Do something. Thank you.